Okay, so welcome to part three. You're almost done. Now you just got to do the topological ordering. So what is a topological ordering? So let's pretend we're making a pizza. We have a bunch of steps, right? So you have to knead the dough, simmer the sauce, put the cheese on, preheat the oven, etc., etc. And the thing is, some steps need to be done before other steps. Like I have to preheat the oven before I put the pizza in. I have to like put the tomatoes in the pot before I simmer the sauce. And these are like dependency relationships. You can think of them as like parent-child relationships in Git, because I need to preheat the oven before I put the pizza in, just like one commit needs to come before another commit to make my code base work properly. So a topological ordering is an ordering of steps which respects all of these parent-child relationships, where I can make my pizza properly without messing up. So for this ordering, like it's just a recipe. So what you see on a recipe to make a pizza, it's just a topological ordering of the steps you need to make the pizza. So for this assignment, we're using these dependencies, these parent-child dependencies, to like make an ordering. And the ordering is kind of backwards, which basically means you start off at these like leaf childless nodes, and then you print those out first, and then you go backwards for the ordering. So in the spec, it says um, all the descendant commit nodes are strictly less than their ancestral commit nodes. So you got to put the descendants before the ancestors. And that's why you want to start off at like the leaf kind of branch nodes and then move backwards from there. So now we've generated a dependency graph of the commits, and we need an algorithm where we input the graph and output an ordering. So we're going to be doing this on the graph that we made for like the space repo that I made up. And here's the algorithm. Honestly, you can try to think of this yourself, but this is the standard algorithm to do this. So what you got to do is first initialize an empty queue. And we're going to use this queue to like order our nodes. And we have to find the nodes with an out degree of 0. So in the context of Git, that means they have no children. They have no arrows. Like in this graph, there's no arrows pointing out of it. So it has an out degree of 0. Um, and then you push all the nodes with an out degree of 0 into the queue. And then you pop the queue, like pluck the node from which is in front of the queue out. And then you add it to like the end of the ordering. And then you remove all the edges going into this node. And then once you do that, you go back to step 2, because now there are new nodes with an out degree of 0 because you just removed some edges. So that is probably confusing. And you repeat this process until there are no more nodes. And this is probably confusing right now, but we are going to demonstrate it on this graph. So let me make a copy of this entire graph. I don't really care about the branches right now. And then put it down here. Oops. And then zoom in. Cool. Okay. So let's make a queue. We're just going to represent the queue like this. Let's use blue text. Queue. I'm going to make the text way bigger so you can see it. Or maybe smaller than that. There we go. And then this is our queue right here. Okay. So first things first is, what do we do first? Well, we initialize an empty queue. We did that. Now we find the nodes with an out degree of 0 and push them into the queue. So those are going to be our branch heads, 4D75C and FFAC5. So let's do 4D75C first. And then, so the front of the queue is going to be like the right side, and the back of the queue is going to be the left side. So we do FFAC. So when we add something, we add it to the left side. So we're going to do it like this. Okay. So 4D75C and FFAC5. Cool. We have that here. And now we are going to pluck the node in front of the queue, and then let's make an ordering too. So this is, I'll make this green, and this is going to be our topo ordering. I don't like it highlighting that, so I'll just do topological. Okay, so right now we just have 4D75C. So yeah, so we plucked the node at the front of the queue out, and then we add to the ordering, and then what do we do? Well, we add the pop node to the end of the ordering, and we remove the edges going into this node. So we're going to get rid of this. Okay, so now we go back, and then we find the nodes with an out degree. So we go back to step 2 now, and we find the nodes with an out degree of 0. Well, we have FFAC5, but that's we currently don't have any nodes with an out degree of 0, because FFAC5 is already in the queue. So now we're going to look at FFAC5. We're going to pluck it from the front of the queue, and then we're going to add it to our ordering. Oops. FF8. Oh, it's going to go at the end. And then we remove all the nodes, all the edges going into this. And then you go back to step 2, and step 2 is find the nodes with an out degree of 0 and add it to the queue. So these are already like in the ordering, so we can ignore them. Now F0FE5 has an out degree of 0 because there's no arrows coming out of it. So now we add that to the queue, E5, and then we pop the queue, and then we add this to the end of our topological ordering. And then we remove all of the edges coming into this node, so we get rid of this arrow. And then look, we have another node with an out degree of 0, F979E. So let's add that to the queue, 79E. And then we pop the queue, add this to the topological ordering. And now that we added this, we can remove all the edges that point into it, so that we get rid of these 2 arrows. Whoops. We get rid of these 2 arrows. And now we have 2 nodes with an out degree of 0. So that's 915EE and 241E9. Oh, we added to the front. The front is on the left, so 41E9. Doesn't really matter, but for the sake of consistency. Okay, so now we pop the node at the front of the queue, 915EE, add it to the end. And then we remove all the edges going into it, which is this arrow. And right now we have nothing to add to the queue since these 2 nodes still have edges coming out of them. But next we pop 241E9 because it's at the front of the queue, add to the ordering, and we remove all the edges coming out of it. And now this node has an out degree of 0. We remove all the edges coming into 241E9, my bad. So now this node CAAF0 has an out degree of 0. So now we're going to add that to our queue, push that into the queue. And then we pop the queue, put the front node into the ordering, and then we remove all the nodes coming into it, which is that arrow. And then finally, our last node has no arrows coming out of it, now degree of 0, so it's 0, 2, 5, 2, 5. And then there's no arrows, so that we put this at the end of our ordering. And then there's no arrows coming into it, so there's nothing to remove, and we've touched all the nodes anyway. So now we're done, and we have generated a topological ordering. So just to confirm, we can put this up here and compare it with our original graph and just do like some quick sanity checks to make sure that all nodes come before their ancestor. So 4D75C, well, there's nothing, like there's no child nodes, so it's good that it's got to be at the front. Then we have FFAC5, again, no child nodes, so it's good that it's at the front. There is 4D75C before it, but FFAC5 is not a child of 4D75C, so this is fine. This ordering is fine. And then we have F0 FE5. It, it's after 4D75C and FFAC5, which is good because it's an ancestor of those two, and everything else comes after it, which is good because it's a descendant of everything that comes after it. And then 5979E. If you go on, you can verify this on your own. It all works just fine. So this topological ordering is valid. Okay, so you can implement this algorithm using Python. Like the specifics are up to you, but hopefully this gave you an idea of how, like, what logic this algorithm uses. You can kind of follow these steps to implement topo sort. And good luck on implementing this. Um, Hopefully you all get it done on time.